Okay, class. Here's some worked out examples from section 4.2. I'm kind of focusing on that versus on 4.1 to get us quickly through the chapter and get us to the end as quickly as possible. So I'm hoping 4.1 that you shouldn't have any trouble with dealing with the expanded view of a number for base 10, because that is some of the foundation, but I'm hoping that should be pretty straightforward of how that works, because it's very similar from algebra. I think we've seen this before with regards to scientific notation type thing. So this is basically building upon that with regards to 4.2, changing from base 10 to another base, or rather from a different base to base 10. Okay. So here's the process again. Find the place value for each digit in the numeral. Multiply each digit in the numeral by its respective place value. Find the sum of the products in step 2. Alright. So now, here's problem number 1 on page 206. And the first step, first thing is convert 43 base 5 into base 10 to find the place value for each digit. Okay, so in the tens position, the place value, or rather it'd be 5 to the first. Just like it was, the place value for base 10 is 10 to the first. Since we're working in base 5, it's 5 to the first. And again, I keep on re-emphasizing that 5 to the 0 equals 1. Okay, which is it's just that the textbook automatically jumps to 1. But I want to emphasize and tell you where we're getting the ones position from is because if we just go numerically down, you're still using the same base. We have to go all the way down to 0 in order to get to the ones, to get to the last position of our number, which is the ones position. Okay. So now, multiply each digit in the numeral by its respective place value. So 4 times 5 to the first, 3 times 1, you get 20 plus 3 equal to 23. Alright, so convert 1101 base 2 to base 10. Alright, so now we're up to 1,000. So thousands means there's a base number, base 2, that's to the third power to represent the thousands position. Hundreds 2 to the second, tens to the 2 to the first, and ones 2 to the 0, which equals to 1. So these are our place values. Thousands, hundreds, tens, and ones. And when we go ahead and multiply each digit by their respective place value, we have to go ahead and do by order of operations first the exponents, then multiply. So 2 to the third gives you 8. 1 times 8 is 8. 1 times 4, or rather 1 to the second power, which is 4, is 4. 0 to the first, 0. 1 times 1 is 1. When you add all this up, you get 13 base 10. Okay. So now, to change a base 10 numeral to another base, we have to go through a succession of division. Okay. And I wrote out some steps to help us really get this down. So evaluate the largest power of 4. That will allow you to begin dividing into 108. And what I mean by the largest power of 4, meaning, or base 4, I should probably say base 4. That something 4 to the certain power, when you evaluate it, will give you a number that is not going to be bigger than 108 to begin the division process. And then in step 2, take the remainder, if one exists, and divide it by a base 4 exponent that's 1 less than the previous. So whatever you start off with, whatever exponent that you had previously to start off the division, the next consecutive division process will be an exponent that will be 1 less than the previous. And you continue with step 2 until you get down to 0. Let's take a look at problem 35. And here, again, this is to convert 108 to base 4. And the largest, and I'll give you some examples. Let's say, for example, 4 to the fourth. Well, 4 to the 4th equals to 256. It's too big. But 4 to the 3rd is 64. It's just right. So we're going to take 64 and divide it into 108. And begin our division process. It goes into one time, and we have a remainder of 44. Now, we don't take 64 again to divide. We take a exponent base 4 that's going to be one less than the previous exponent base 4 that we had. So 64 was 4 to the 3rd, so the next one's going to be 4 to the 2nd, which is 16. And you begin that division process. 16 goes into 44 two times, lose your remainder of 12. Then you come down and do 4 to the 1st, dividing into 12, which is 3. And you still go ahead and do 1 divided into 0, just for the sake of neatness, so that you can actually see all your quotients line up. And if you notice, in red, 1, 2, 3, 0, boom. That is your answer. These are the quotients. The 1, 2, 3, and 0 are the quotients. So therefore, that is your answer in base 4. 1,230 base 4. And typically, here's another, I should have typed this up in the notes, or at least on the slide, is that when you're converting from base 10 into another base, typically your resulting answer is going to be something larger than what you started off with. Okay? Because it's going to take more groups of a smaller base to find the equivalent for. Okay? So that's pretty much it. Alright, hopefully this makes some sense to you. Again, take a look at the virtual class session, because we'll be working on some more, but this you can use as well. Alright, thank you.